The absolute value of a number is its distance from 0 on a number line. So we can see that this point here at 7 is a distance of 7 units from 0, but this point here at -7 is also a distance of 7 units from 0. Because distance is a measurement, it is never going to be negative. We're always taking the positive value because we're asking how far is it from 0, not in what direction are we moving it. We use this bar notation to represent absolute value, so we would read this as the absolute value of n. This inside is what we call the argument of. So the absolute value of 6 is 6. This just means that we're 6 units away from 0. The absolute value of -6 is also going to be 6. We are 6 units away from 0. When trying to get the value of this expression, the bar notation for absolute value functions like the brackets or parentheses on other equations that you may have seen. So we're still going to follow BEDMAS, beginning with those brackets. Now, if you get something like this, you can see that there's a whole bunch of vertical lines. So what I would probably do right off the bat is go from left to right. So there is kind of like the opening bracket, there is kind of like the closing bracket. So we're going to take the absolute value of this piece, then we're going to come across another one that opens, and so that next one is going to close it. So we're going to also take the absolute value of this piece. And same thing on this side. So I'm going to go from left to right, open and close. So we need to take the absolute value of that section. And then you can see here that we just closed that piece. So now we're going to open it again and we're going to close it. So now we're going to take the absolute value of this piece. That helps you avoid taking the absolute value of that by mistake. And again, we just closed it. We're going to open it and then we're going to close it at the next one. So we're going to start by getting the value of each of those sections. Then we're going to take the absolute value of it and then work through the rest of the processes. All right, so we're going to begin 3 minus 5 is -2. So then in this one, we have to multiply first. So we're going to go 2 minus 4 times 3 is 12. And then we can go ahead, take the absolute value of -2, and we get +2, minus 2 minus 12 is -10. When we take the absolute value of that, it becomes +10. 2 minus 10 gives us a final value of -8. So it's okay if the final answer is negative. We're just taking the absolute value of each section as indicated. All right, on our next one here. So we're going to begin with 3 squared is 9. So we have 6 minus 9 is going to be -3. And just like order of operations, I'm just bringing the rest of the pieces down. 2 times -4 is -8, plus 5 is -3, and we have -3 times -1 is +3, plus 2 is 5, and then I'm going to go ahead and take the absolute value. So -3, the absolute value of it is +3, -3, same thing, take the absolute value, and +5 is still represented as +5. Next we do multiplication, so we're going to have -2 times 3 is going to give us that -6 value, -3 times 3 is -9, and then 1 minus 6 is -5, minus 9 is going to be -14, minus another 5 is -19, and again, your final answer can be negative. And then if you wanted to verify your answer, there is an absolute value sign on your calculator. So if you go into math and then arrow over to the number menu, number 1 is absolute value. So if we press enter, we can type in 3 minus 5, and then you're going to right arrow out of that, and then minus math, and again, arrow over to the number menu. Number 1 is absolute value. And then we can go 2 minus, and then 4 times 3, or you can enter it directly with the brackets. And then if we press enter, we can verify our answer. If you're using a TI-83, when you press that absolute value, you're going to see a round bracket that shows up. So you just have to make sure you close it at the end there. Let's take a look at an example. So we have a race, and the possible length of that trail is 2 kilometers. Because my checkpoint stops are given in meters, I'm just going to convert that 2 kilometers into 2,000 meters. And then I'm going to kind of break this up. So halfway would be 1,000, and then 500, 1,500. So we're told that we have a check stop at 900 meters and 1,600 meters. So I've just plotted those points. Our particular race organizer is going to go from the start to the 1,600 meter line. So let's go ahead and draw that in here so we can see that. And then after that, they're going to go from the 1,600 meters back to the 900 meters. So we're going to put that in there. Then we're going from the 900 meters to the finish line. So we're going to the end there. And then we're going back to the 500 meter point. We know that we can find the total distance for any given interval by taking where they finished minus where they started, that absolute value is going to give us how far they traveled. So we're going to set up our equation first of all. So let's begin by setting up our expression. So the first one, we finish at 1600 meters. We began at 0 at that starting point. We then finished at 900 meters. We began where we left off, which was that 1600 meter point there. We then finish at the finish line, 2000 meters. We started that interval at the 900 meters where we previously left off. And then we end up at the 500 meter checkpoint, and we began at that 2000 meter finish line. So then 1600 minus 0 is 1600. 900 minus 1600 is negative 700. Take the absolute value and it becomes positive 700. 2000 minus 900 is the 1100. 500 minus 2000 is negative 1500. Take the absolute value and it becomes positive 1500. Add them together to get the total distance, which is going to give us 4900 meters. And then in kilometers, it's going to be 4.9 kilometers. We know the absolute value of 5 is 5. The absolute value of negative 5 is 5. The absolute value of 8 is 8. The absolute value of negative 8 is also 8. So we're going to throw some variables in here now. So we can see that if what's in here is positive, then we're just getting that value once we take the absolute value of that. If what's in here is negative, we're getting the opposite value. So it's kind of like we're multiplying by a negative 1. If what's in here is negative, we're getting the opposite value. If what's in here is negative, we're getting the opposite value. So let's say that we take the absolute value of x. What could x be? Well, we've got two different scenarios that could happen. So if x happens to be positive, we know that when we take the absolute value of a positive x, we get that same value back. So if I take the absolute value of this, and this happens to be a positive number, I know it's going to equal this, which means that x will just be 6. But if we happen to have a negative value for x, so x is less than 0, when we take the absolute value, it's going to be the opposite of what this value was. So x would have been negative 6, take the absolute value of it, and then that sign is going to flip. So anytime we take the absolute value of any expression in here that contains a variable, we're going to have two different scenarios that occur. So we're going to define it in two different parts, which is what brings us to what we call a piecewise function. We're going to get more into the function part of a piecewise function in our next lesson, but it's basically where we're taking a function and we're breaking it into parts or pieces, and we're saying for this piece, we're looking at x values of this. For this piece, we're looking at x values for this. So we're looking specifically for x values in that domain. Remember, that's on the x-axis, and we're going to put all those pieces together to get one overall function. So if this in here happens to be positive, we know that when we take the absolute value of a positive, we get that exact same thing back. So it's going to be what we see in here is what we get if that happens to be positive. If what we see in here happens to be negative, then we know we're going to get the opposite of that when we take the absolute value. And then I'm going to go ahead and actually put greater than or equals to 0 here, because if x is equal to 0, the absolute value of 0 is still going to be 0. So this is what we call a piecewise function. So when I take the absolute value of x, I'm going to get the same thing back if x happens to be a positive number originally. I'm going to get the opposite if x was originally a negative number. Okay, so we have an expression containing a variable within the absolute value sign. So if I take the absolute value of x minus 2, I know that if that expression was positive or equal to 0, when I take the absolute value of a positive expression, I'm going to get that exact same expression back. If this expression, however, happens to be negative, I know that this originally was the opposite value of what we see. So we're going to have the opposite of what we originally see in there. And then I can go ahead and simplify this. So in terms of the domain restriction, which is what this is, I'm going to isolate x by adding 2 to each side. And then I can also distribute this negative sign into the brackets to eliminate those brackets here. So this one can simplify just into negative x plus 2, and that's going to occur when x is less than 2. All right, so again, we have the absolute value of an expression containing a variable. So I know that if this expression happens to be positive, then when we take the absolute value of that expression, we are going to get exactly what we see originally. If this expression happens to be negative, we know that when we take the absolute value, we're going to get the opposite of what that expression originally was. So then we can go ahead and simplify this. So in terms of the domain, if I want to isolate for x, I'm going to subtract 1. So I'm going to bring this over and get negative 1. I'm going to divide out the 3. So when x is greater than or equal to negative 1/3, we're going to get the exact same thing if this happens to be positive. If this happens to be negative originally, then we're going to get the opposite. And then in this last one, you're going to notice that we have a degree 2 expression. Is there any way that this expression will ever be negative? If I were to have a negative value for x, as soon as we square it, it's going to become a positive. So in this particular case, there is no way I will ever get a negative expression here. So when we take the absolute value, we're going to get the exact same expression, and that will occur for all real numbers of x.